So, Jiva, we're going to talk about protocols. To me, it just sounds like something from a spy movie or something. But what do we mean by protocol in Objective-C?
Well, essentially, a protocol defines an interface that can be implemented by multiple other classes without the use of inheritance. So, in other words, it's most often used in cases where maybe you want to define an interface that you want to program to, but you don't necessarily want to restrict the user of your API to just inheriting from whatever classes you've programmed to. Usually we see this in the delegate pattern, for example. And the delegate pattern is one that's used often in Objective-C. It's one of the most common design patterns used in Objective-C. In fact, we're going to use it here to illustrate protocols, so it's probably a good opportunity for us to review the delegate pattern and kind of see how it works.
So when you say interface, you literally just mean a series of methods that something will support.
Yes, exactly.
Which normally you might think, okay, I want to ensure that this class has these methods, so it must inherit from my base class for this. But We're saying protocols give us a way of not having to rely on that base class hierarchy.
Exactly.
Okay.
Instead of saying, we're going to rely on this whole big chain of classes, instead we're just saying, look, I don't care what kind of class you are. All I care about is whether you implement these behaviors, because that's the only important thing that I really need to know, is that I can send you a message by calling a method, and you'll respond properly to that message. And that's really the essence of what a protocol is.
Okay, that sounds cool and really flexible.
Yeah, definitely. So if you look at this diagram, this is actually essentially what the delegate pattern looks like in Objective-C. Essentially, the idea is you have some class, in this particular case, the foo class, right? And usually, not always, but usually, this is the owning class of some other object, for example, bar, which has a member variable, which is usually called delegate, and which is said to implement some interface, right, which the foo class then inherits or implements. This is where we're using this idea of a protocol here. And so the idea is that after creating the instance of bar, okay, then you set yourself as the delegate of bar, and then bar can then send it messages about its state. Again, the reason it can do that is because foo is said to implement that protocol and that interface.
That's starting to become clear. So bar wants to tell things about what it's doing, for example.
Exactly.
But you don't want to write the bar class to have to know about every class that's out there.
Right.
You don't want to limit it to only be able to talk to something from a certain object hierarchy.
Right.
And so we're saying here, if a class sets itself as a delegate of bar, bar can talk to any class as long as that class supports the methods that are defined in the protocol defined for that delegate.
Which is bar delegate in this particular diagram, right?
All clear now.
Exactly. So the cool thing about this is that bar doesn't really have to know anything about foo itself, the actual concrete class foo. It doesn't need to know what it inherits from. It doesn't have to know what kind of class it is. It doesn't have to know anything about anything other than the fact that it inherits or that it implements the bar delegate protocol, right? And the reason that this is, a really powerful concept is because essentially it allows you to delegate responsibility for logic that you would normally do yourself to your delegate, to somebody else. So in other words, you can say, look, I'm going to do something and there might be an error condition that might occur. I don't know what to do with that error because I'm just a lowly, under the covers kind of a class. You who are using me are more likely to know what to do with that error, whether you want to display an error message or ignore it or whatever else. So rather than me delegating or me telling you what you're going to do, in other words, like throwing an exception or something which forces you to handle this, the delegate pattern allows the object to ask its delegate, what should I do in this kind of a case? And the key technology that it uses to do that is a protocol.
A protocol, right.
So let's take a look at protocols. To create a protocol, first of all, this is actually an example of a protocol. Again, it's a delegate protocol for just some fictional web app client. Okay, so let's say that you have this web app client class that maybe connects to your web application and pulls down data and stuff like that. And it probably will pull down the data. Maybe it's got some error conditions that it's got to deal with and things like that, right? So the idea is we have this class. It's called web app client. And then we have a delegate in here. Now, that's more related to the delegate here. But the delegate is actually, and it's a class that implements this protocol, web app client delegate. Now, right. I'll get into the details down here of what these angle brackets are and things like that in a minute when we talk about how we tell that a given object implements a protocol. Right now, I want to first focus on actually declaring the protocol itself, right? And in this case, the protocol that we're declaring is this web app client delegate protocol. So the first thing that you do is you have this @ protocol, right? And that basically tells the compiler, just like when we had @ interface for classes, it's telling the compiler that we're about to declare a protocol.
Yeah.
Then we have the name of the protocol. In this particular case, it's web app client delegate. Then we have an optional ability to specify that this protocol also must adhere to some other protocol. In other words, we could, if we wanted to, we could take off this little bit right here, and that would be a perfectly valid protocol definition. Now, I'm including this here for some things that we'll be doing later, though. So just understand that what we're saying here is that we're creating this protocol. It's web app client delegate, and this protocol also adheres to the NSObject protocol as well.
Okay.
Okay. Once you've started this declaration of the protocol, then you start putting in the method signatures for the protocol's methods. So in this particular case, we have this method, web app client got data.
Right.
Now, this is pretty standard for a delegate protocol method where you have the web app client and then you're passing in the object that this is a delegate of. But that's not necessary in all protocol methods. This can be any method declaration that you would use anywhere else.
These are just Objective-C declarations.
They're just Objective-C declarations. So now, protocols, a formal protocol, which is what this is. We'll talk about formal and informal protocols in a minute. But for formal protocols, that is protocols that are declared using the @ protocol keyword, they can have both required and optional methods. You don't have to implement all of the methods that are part of the protocol. Mm-hmm. The default is for any of the methods that are listed inside the protocol is that they are required. But if you want to have an optional method as part of your protocol, then you can use the @optional keyword to indicate that all methods after this, until you see the @end or another @required keyword, will be considered to be optional methods. So in other words, this method here, this web app client disconnected method, is an optional method. The classes that implement this protocol are not required to implement this particular method. They are required to implement this web app client got data method.
So in order to be able to say that I implement the web app client delegate protocol, you have to implement web app client because that's a required method. But the optional ones you can choose to implement or not.
That's correct. So, so you can list multiple methods here. You can have a whole list of methods here, either in the optional or in the required block. And then obviously when you're finished with the protocol declaration, just like your interface declarations, there's an @end at the end of that ends the protocol declaration.
So if you have no optional ones, you don't need to include the optional keyword?
Correct.
Okay.
Then all of your methods would be simply required.
Yep.
Now, one of the key aspects of a protocol is that a protocol is just an interface. There's no provided implementation. The implementation is expected to be provided by the classes that implement the interface.
Right.
So in other words, even though in this particular case, I've actually put this protocol right into my header file for my web app client, which is pretty common when it comes to the delegate pattern. A lot of times you'll see protocols just in their own header files all by themselves. And often in that case, it's just in the header file and there's no .m file at all.
Right, okay.
Just a .h, no .m. And the key thing to think about that is it's nothing but an interface. There's no implementation. The actual implementation of the methods is going to be done on the classes that implement that protocol. So let's take a quick look at that.
Okay.
In this case, I've got another class over here called NetConnector. And in this case, this would be, if we've got this web app client, maybe this is a class that connects to a web app client, and maybe it connects to some other service as well. And so this is sort of your interface between that web app client code, which maybe you've written previously for accessing your specialized web app. Now this is sort of your connector between your application and that code.
Yep.
So to state that a class implements a protocol, you simply list the protocol name in angle brackets after your parent class in your interface declaration. So by doing this here, what we're doing is we're saying we're creating an interface at interface. We're naming this interface for this class NetConnector. It inherits from NSObject, right? And it implements the web app client delegate protocol.
And if I was implementing more than one protocol, I would just have a list, would I?
Yes, you could just put it on the end of this. You could put comma, right. And then you could put
all go in
whatever you wanted
brackets,
to, just like anything else.
Yep.
So by doing this now, once I've listed this, then all of those required methods from my web app client delegate protocol must have an implementation now on this class. If I don't, I'll get a warning from the compiler.
Okay.
So we can then jump over to so in other words, you can then take that and you then have to implement those methods on this particular class.
Okay. Because you've just contractually agreed to by saying I support the protocol. Exactly.
Now, once you've done that, you can assign, or you can then use that NetConnector as the delegate for the web app client, because it now adheres to the web app client delegate protocol. Mm-hmm. So in doing that, then, we would actually assign that NetConnector to this web app client delegate member variable. Mm-hmm. Now, the syntax for stating that a member variable, or any variable really, adheres to a protocol, because what's going to happen is it's going to check when you assign this delegate to see if it actually adheres to whatever protocols you've said that it needs to adhere to. Mm-hmm. And that's exactly what we're doing here in this ID web app client delegate in angle brackets member variable name. Right. So in other words, here this is the same kind of thing. We've got that protocol in there, and this is stating that whatever is assigned to this delegate variable has to adhere to that protocol.
So it's saying the type of the object that needs to go in here is ID. Now ID is our generic type, meaning any object.
Yes.
Okay, so that means we can put any object in here, but the fact that, again, after the type comes the angle bracket saying, but it must support this protocol.
Precisely, exactly.
Okay. And again, if there were multiple protocols it had to support, you just list them out? Or?
You could just list them out if you wanted to.
Right, so I mean, if you wish to, for other reasons, you could say it needs to be of a descendant of class X,
right,
but also support this protocol. Right. It doesn't have to be just ID.
Right, and a key there also is to realize that not only does it have to support that, but you were mentioning listing them out, that would also have to support any of the protocols that are listed as being required for that protocol as well, that NSObject protocol.
But we'd only need to declare that would all be picked up
implicitly
by the fact that our protocol has already declared that.
Precisely. Now, kind of shifting gears just a little bit to the delegate pattern specifically, I wanted to point out the delegate pattern in Objective-C, this delegate that we're assigning in here is one of those rare cases where you're dealing with objects and you want to make sure that when you are assigning this delegate value to your delegate variable, it's got an assign attribute as part of your property as opposed to a retain or a copy. And the reason for that is essentially going back to that same diagram, because the object that may be used as the delegate may also be the owner of the thing that's doing the delegation. And so as a result, if you had retains on both of those, you'd have a retain cycle and nothing would ever get
because you can assign yourself as the delegate to yourself.
Exactly.
Okay. And what about the garbage collection? Because it's going to have a connector to it, or does garbage collection sort of realize it's a delegate?
Garbage collection takes care of that automatically.
Because it's got special stuff in to recognize delegates.
Yep.
That's how often delegates are used in this thing, that it recognizes it.
Yes,
for
it
us.
does.
Okay.
So now the next question is, so if I wanted to then, so now if we look at this code here, at this interface, and we say we have web app client, which has a delegate, which implements the web app client delegate protocol. Now in web app client, we want to actually use this object to send messages. Now, so if you look at this again, the whole goal behind the protocol here is that I'm giving another class an opportunity to affect my behavior. I'm delegating responsibility to that. So let's take a look at how we send messages to the delegate. It's very simple, and this is the same way that it works with all protocols. If you have an object that adheres to a particular protocol and you want to send a message to it, it's just like making any other method call. Basically, we're doing delegate, web app client, self, got data, in data. It's just using that method right there, just like if we were using it anywhere else.
And because of the safety factor within Objective-C that nil can have stuff called on it, if no one's assigned a delegate, it just does nothing.
Exactly, which is one of the cool things about the delegate pattern in Objective-C. Also, the fact that we've declared here that the delegate object adheres to that protocol gives the compiler the opportunity at this point to verify that the delegate in fact does implement that and that is a valid message to call to it. So that's how you basically call a message on that. Now, we talked a little bit about this optional guy here, right? Mm-hmm. And so what happens if I optionally choose not to implement this particular method on my delegate object?
I'm assuming that if we tried to call it and it wasn't supported, things would go bad.
Bad things would happen. We would actually get an exception. The exception that would come up is something along the lines of object does not respond to selector or something along those lines. So it's important whenever you're dealing with optional methods, you want to make sure before you try to call the optional method on that protocol that the object responds to that particular message. Because it's optional, the object has the option not to implement it. So you have to say, do you implement this? And then call it. And the way that you do that is down here. As you can see, we've got this disconnected method. And the first thing that we do before we call this is we say, hey, delegate, do you respond to selector, right? Using the responds to selector method. And then again, we're using this @selector command, which I think we've seen a little bit here and there. What that does basically is it gets the selector based off of a string that we pass it in there, this web app client disconnected. The selector is the method itself. So we're basically saying, delegate, do you respond to this message, essentially, right?
We don't need to worry too much about how it's working. We just need to know that's the syntax.
That's the syntax right there. If this responds yes, then we can go ahead and actually call the message on there.
So that's basically testing, asking the object that is currently assigned to the delegate, do you support this method?
Yes.
That's all built into Objective-C.
Yep.
It's part of the NSObject stuff. And
yes. And in fact, actually, that right there is why we're doing this here with the NS object because the response to selector method is part of the NS object protocol. So what we're saying is we're going to need to use this response to selector method as well. And so that's why we need to make sure that we also are implementing the NS object
But
protocol.
as everything descends from NS object, it's going to support it anyway, isn't it?
It is.
So
But you still have to declare it.
Do we? Okay.
Yeah.
Right.
Otherwise, you'll just get it'll work, but you'll get a compilation warning.
Because it's not sure it's going to. Okay.
It doesn't know.
Right. So we check if it supports the method, and if it does support the method, we call it.
Exactly.
Okay. So obviously we only want to make methods optional on a protocol if they're non-vital.
Yeah. I mean, if it's something that you can safely, for example, implement some kind of default behavior for or something, that's probably perfectly acceptable. It's easier when you're writing out the protocol to just say required on anything, then you don't have to do all this extra work of response to selector and things. But at the same time, it can be a pain for people who are implementing your protocol if there's all of these required methods and, maybe I just don't care if the client disconnected. Maybe I only care about receiving data or something along those lines, right?
So this whole protocol system can be used for anything you want, but we've just demonstrated being used for a delegate because that helps us also describe the delegate pattern.
Right.
Because you are going to find that in
It's all over the place.
almost any.
Right.
I mean, a good example. Let's
NS
take
URL connection is a great example.
Yeah, or even let's move into the iPhone or whatever. A table.
Right. Yeah.
It's going to use the delegate method to ask another class to give it its data.
Yes, exactly. UI table view does that all the time.
So I mean, if you don't know about delegates, especially on the iPhone and the iPad, you're stuffed.
That's definitely.
So
it's
although
a vital.
Make sure you
pattern.
understand this delegate pattern as well as protocols, because if you're writing an iOS or a Cocoa, I think it's common enough in Cocoa that you're going to need it there as well. Without doubt, you're going to need this to understand the code you're reading. So make sure you understand the pattern and protocols.
Definitely. Now there was a couple of other little things that I'd like to just point out in here because we have them in this code. We haven't really discussed them, and they come up often enough, like when you're designing delegates and when you're designing protocols, that I just wanted to point it out. And that is this little guy here, this @class web app client. In this particular case here, we have a case where we are passing a web app client to this web app client delegate protocol method. And so as a result, because that interface is declared down here beneath the protocol interface, right? And at the same time, we also need to use the web app client delegate protocol interface down here in the web app client interface.
So it wouldn't matter which way around we put them, one of them would require the other that hadn't been declared yet.
We'd be pooched either way.
Yeah.
So because of that, we need to forward declare our class, the web app client class, which basically is telling the compiler, hey, I'm going to implement or I'm going to declare my web app client interface later, but I just wanted you to know that it's going to be coming up and it's going to be valid.
It's a compiler version of Trust Me?
I think so.
Yeah.
So there's that kind of situation. You want to make sure you take that into consideration when you're working with these protocols, in particular when you are defining a delegate such as this. Another situation that comes up sometimes is cases where you have a circular reference. So for example, if you can imagine, here's another protocol, and in this case, it's a protocol that actually requires another protocol for its own methods. So we have this some method requiring bar, which is another protocol. It's, as you can see, we've specified ID, and we've got the angle brackets over here for this bar.
Okay.
So the bar parameter that's specified in here is said to be adhering to the bar protocol. Now, that looks okay.
We could pass anything as long as it complies to that protocol.
As long as it complies to that, we're all good. Now, just off the cuff, that's perfectly fine. But what if we then have bar over here that also requires foo? Then we have a little bit of a problem because we have another one of those circular references. I need to define a bar protocol that knows about foo, and I need to define a foo protocol that knows about bar, and so on and so forth. So just like there's the @class forward declaration syntax, there's also an @protocol forward declaration syntax that can be used to say, hey, I promise I'm making you a foo protocol. Trust me, it's coming, and it lets you get over that particular problem.
That's useful to know, because that's maybe not very, very, very common, but it's not so uncommon that you're not going to come across
Right. It's just a little something to know about. There's one more thing that we really kind of need to cover if we're going to cover protocols correctly. Everything that we've talked about so far really has to do with formal protocols. And formal protocols are the more modern syntax of protocols. It's another one of those newer features in Objective-C. It's available on Mac OS X and iOS, and it's not something you won't see a lot of. I mean, it's out there. It's been out there for a while, but it's really the newer syntax. It is the preferred syntax. If you are creating new protocols, you should really use formal protocols, because it really allows you more flexibility and more type safety when you're declaring your protocols. But just because there is a certain amount of legacy code out there, and even some of the Mac OS X frameworks use them, there's another concept called an informal protocol. And an informal protocol really works almost the same way, except that you don't have to declare the protocol in a formal way like we do with these @protocol commands. Instead, informal protocols are actually declared as categories, which is the topic that we'll cover in the next section, on NSObject. So, we'll talk about it a little bit more when we talk about categories, but I just wanted to point out that essentially an informal protocol is a category on NSObject, and you simply adopt an informal protocol by implementing whatever methods are in the informal protocol. You don't actually have to say, hey, I've got this object out here that implements this protocol, because it's not possible to actually do any kind of type safety checking on an informal protocol.
And so we'll pick that up when we do categories.
Absolutely.
Okay, so what are we doing next?
Categories.
That's convenient then, isn't it? So we'll come back in a minute and do categories.